All right, so here's question 6. This is your differential equation in slope field. I don't know how they're going to do this on the exam this year, but they may have you trace where solutions are supposed to go on a screen. So I still want to go over this. They may still ask you this. All right, so we're given this differential equation, dy dx. They gave the slope field, so we didn't have to draw it. Sketch the solution curve that passes through the point 0, 2, they have that labeled, and 1, 0. So all you have to do is start at that point, follow the slopes, and just make sure you go all the way to the edges. If you don't, they won't give you credit. This one's easy because it's just going to be a horizontal line. But look, if you were to do this, they would not give you credit. It has to go all the way to the edges. So I would recommend just even going beyond it a little bit just to make sure that you are going to get that. All right, and then here is 1, 0. Again, you want to just follow along with the slopes, but don't like go through any of the other ones. So I'm not like super great at this, but you kind of just want to follow along with something like that. There, that's pretty good. All right, part B. That was all for part A. You just had to draw the solutions through those 2 points. Part B, I'm just going to do this down here. Let f of x be the particular solution with the initial condition 1, 0. Write an equation for the line tangent to the graph. All right, for a tangent line, you need a point and you need a slope. So for the tangent line, you need a point, you need a slope. They gave you the point, it's 1, 0. Slope comes from the derivative, which they gave right here. So, actually, let me just copy dy dx down a little bit lower here so that we can see it and I can move the paper down. So there's our derivative. We're going to plug in 1 for x and 0 for y, and that will give us our slope. So x is 1, that's just going to be 1/3 times y is 0. So 0 minus 2 would be -2, squared is 4. So our slope is 4/3. And then write your equation. It's y minus 0 equals 4/3 x minus 1. And then they asked us to use that equation to approximate f of 0.7. So all you have to do is plug in 0.7 for x. You do not have to simplify it down. Just leave it like that. Oh, I put the parenthesis in the wrong spot. You need your parenthesis in the right place, or that's going to make it wrong. Put in 0.7 for x and then -1. Now for this one, it was y minus 0. So we didn't have to move that to the other side, but pretend this was y minus 3. You would have to add this 3 to the other side and you'd have a +3. I'm just bringing it up because if it's a number other than 0, then you're going to have to do that. All right, part C is asking us to solve the differential equation. So first, separate the variables. We're going to divide over this y minus 2 squared. That's going to make it y minus 2 to the -2. And we're dividing that over dy and then multiply over the dx. I hope I have enough room for this here. Let's see if it fits. All right, antiderivative. You're going to add 1 to this power. So y minus 2 to the -1. And then divide by that. So you need a negative out front. You can do a u substitution if you want, but the derivative of 2 is nothing since that's a constant. So just keep the y minus 2 in. All right, over here, this would be 1/2 x squared, but there's already a 1/3 there. So 1/2 times 1/3 would be a 6. So 1/6 x squared plus c. Before I plug in the initial condition, I want to fix this so it's not a negative exponent. It's going to be -1 over y minus 2. All right, and now we're going to plug in 1 for x. So this side will just be 1/6 plus c, 0 for y. So this would be -2 in the denominator. Negatives are going to cancel, which would be a 1/2. So that would be 3/6. Subtract over the 1/6 would be 2/6, which is a 1/3. So again, this would be 3/6 minus 1/6 would be 2/6, which would be a 1/3. Or you could write 2/6. All right, I'm going to copy over this line, but put in that 1/3, and then we're going to solve for y. So what's going to happen is this y minus 2 is going to get multiplied over here, and all of this is going to get divided over here. So what I put in parentheses is just going to switch places. Again, algebra just means that you're moving stuff. All right, and so that's going to equal y minus 2, and I'm going to erase and just fix this because I ran out of space here. Just barely fit it in. You're going to have to add this 2 to the other side to get y by itself. Again, I do not know how they're going to ask this differential equation stuff on the AP exam, because I don't know how you would type all this in on the computer, and they're not having you upload work, but it's still fair game for multiple choice, and they might find a creative way to ask it on the free response, so you still need to know it. All right, points. It was a point for each of those solution curves. Down here, it was a point for writing out this equation and a point for the answer. And then for the differential equation, it was a point for separating the variables, 2 points for the antiderivatives. So I like to hope they would give you 1 for this and 1 for this, and it wouldn't be 2 all or nothing. A point for getting C equals a third, and then a point for your final answer.